Number 1, frames of reference. Objects in the sky rise in the east and set in the west because of the rotation of Earth. Objects are not revolving around the Earth. Our frame of reference is from the Earth, which is moving, making us believe that we are stationary and everything else is moving. So a frame of reference is how you view things. Because we are viewing the solar system from Earth, which is actually moving itself, it makes us believe that everything is moving around us instead of us moving. So back in the day, some observations that were made was that stars make patterns or constellations, and these groups move together. So they don't all move independently of one another. Each day, they noticed that a star rises and sets 4 minutes earlier than the day before. This changes what stars are in view each month and allowed the prediction of seasons and development of calendars. So if it rose and set 4 minutes earlier each day, at some point it won't be in view and they would know what season it was. The sun rises and sets at a different rate than the stars, though. And the moon rises and sets at a different rate than the stars, and it also has phases, which I put a little link in our course website about the phases of the moon. This isn't something we really talk about in this class, though. Special stars, which were actually 5 other planets, rose and set at different rates from the regular stars in constellations. So they were special in some way, but they weren't sure exactly how. So by looking at the night sky, they made all of these observations and then started to try and piece it together. They also took measurements of the sky. They used 2 coordinates and they are measured in degrees, like the angles of a triangle. The azimuth is measured clockwise from north, and it's measured with a compass. So if you look north or set your compass north, where is the star in relation clockwise from north? Additionally, they measured with the altitude, the angle above the horizon. This is measured with an astrolabe. Together, these form the altitude-azimuth coordinates, and they described things in the sky. There was a problem with this, though. Measurements are based on location on Earth, and the Earth is always moving. Therefore, the coordinates depend on the time, the day, and the place that they are measured from. So, for instance, if you measure the location of the moon at 10 p.m. in Calgary, and a friend measures the location of the moon 10 p.m. the next day in Sydney, they would not be the same measurements. Additionally, we also have to think that stars rise and fall and set 4 minutes different each day. So the day is important as well. The frame of reference. Rather than using the Earth as a frame of reference to study celestial bodies, it's better to use the stars. So we reference the position of something in the sky, like a planet, in comparison to a particular star. This allows us to truly understand the motion of that body, rather than the motion of it in relation to Earth, because Earth is moving as well. So we get the Earth-centered model from their observations and original thoughts. It was believed that the Earth was the center of the solar system, okay? That everything revolved around the Earth. And so they put them in orbits around based on probably how long it took to rotate around. This is called a geocentric model. The planets, the moons, and the sun circle or orbit the Earth. So notice our moon orbits the Earth, other planets orbit the Earth, and the sun orbits the Earth. This was proposed by Aristotle and lasted for about 2,000 years. This was the model that was believed for 2,000 years. Some motions couldn't be predicted by this model, though, such as the motions of the planets Mars, Jupiter, and Saturn. They would sometimes reverse their direction around the sun. So they would be changing direction every once in a while, and it wasn't understood as to why. Ptolemy came up with an updated model. Sorry, this was a terrible picture, it seems. He only tried to adjust Aristotle's geocentric model. He didn't make up something completely new. What he added was epicycles to try and account for these problems. Really, it just made it more complex. So he said that things were orbiting and they would also spin in their orbit. So kind of corkscrew around, if you will. In the 1500s, Copernicus took all of the observations that had been made throughout time and compared it against the geocentric model, where the Earth is the center of the universe, and realized that that just didn't work. So we went back to the drawing board and came up with the sun-centered model. This is called the heliocentric model. So in this model, the sun is a fixed point, and Earth and other planets rotate around it. For practice, take a look at the learning guide for frames of reference, and there's some extra practice in your textbook on page 365. I would recommend 4, 5, and 6.